Now, this illustration deals with commercial and industrial receptacles in accordance with 210.11b and 210.19a1a, which deals with either continuous or non-continuous loads, or maybe in some cases, receptacles that would have a demand factor applied, as mentioned in the previous figure. Now, if we notice in the NEC loop, as we review it, notice that 384-16D per 1999 NEC said, gave an 80% rule. And it basically said continuous loading of overcurrent devices that supplied lights and receptacles and so forth. If you had a 20 amp device, you take 80% of it, that'd be 16 amp. But the 80% rule was causing circuits to be oversized. So they did away with the 80% rule after the 1999 NEC, and they came up with 210.19A1A and said, no, take the load by 125% if it's continuous, and that derates the 80% loading. And then any other load, just take it 100%, or with demands, whatever the code may permit. Now, next, you see that we start with 210.11b and 210.19a1 for that 125% rule also. Now, the elements for continuous duty in this illustration has to be sized at 125%. And in 210.3, it's the overcurrent device rating that determines the branch circuit. Say that you increase the ungrounded conductors to number 10 for voltage drop. With the number 10 conductors at 30 amps, say, would not determine, or maybe even at 35 amps, or maybe the 40 amps is used for derating purposes and so forth. But if the overcurrent device was 20 amps ahead of the number 10 conductors, that's what 210.3 as well as 210.19 is illustrating, that it's the overcurrent device that determines the rating of the circuit, not the size of the conductors. Now we're going to review a quick calc up above, and notice 220.14L just basically says if you don't know what the outlet value is that you're going to take power from, just take 180 VA, and if you had 10 outlets, that'd be 1800 VA. And then the application of 210.19A1A, 125% of 1800, there's the load. So we'd have 2250 or 2250 VA, and we would increase it 125% because of the continuous loading, and we could only have 10 outlets. But notice if it was 18 VA, non-continuous, and it would just remain at 18 kV, excuse me, not kVA, but 1800 volt amps, and that would be the number of outlets that you could put on when you did your math. So this illustration is showing lighting and receptacle outlets are limited to 10 because they are continuous duty, continuous operation, as shown and illustrated to the left top of the illustration. So this illustration then is also showing that overcurrent device at 20 amps was calculated at 125% for continuous duty in accordance with 210.19A1A to derive derating it 80% and in accordance with 210.20A. So as a summary then, 125% of the load, say, sized to 20 amp overcurrent device. 210.20A, we just derated it 80%, which tells you and I, as designers, installers, or inspectors, that the 125% derated the loading of the breaker or reduced it down to 80% of 20, which would be 16 amp. Now, figure 11-4 little b is illustrating commercial and industrial receptacles and how they would be calculated in accordance with 210.11b as in boy, and applying the continuous or non-continuous operation rule of 210.19a1a.